Can you see my screen?
Yes.
Okay, perfect. So if something is varying from the standard, that is variation, and variation in the quality, let's say iPhone weight is a standard weight. They have decided that any iPhone should be 213 gram or 200 something gram. And if it is going more or less from 213 gram, then there is a quality situation, quality concern, and one has to check and one has to correct. In order to do that, one has to do the statistical quality control. So this is all for reading, and and here you can see these are the different people who contributed in the quality control: Seward, Deming, Juran, all. So it's all about for reading, no nothing. And these are the 14 points of Deming for quality. Yeah, this is most important thing: statistical quality control. And these are the tools we have: Pareto diagram, scatter plot, box plot, fishbone, and check sheets. So look into that. And then we have control charts. So let me show you. So Minitab has all these options. Under statistics, we have quality control charts. We have quality tools here. Can you see here? We have Pareto charts right here. Pareto charts, those who are new into the quality or those who have never studied quality management, it is also called 80-20 rules. Means 80% of performance can be fixed or can be improved by fixing 20% of the problems or 20% of the issues. So this is also, it is the combination of two graphs. One is bar and other is ogive. So where is, so that we covered in 503 Pareto chart. Cause and effect. It's also called fishbone diagram. It is also called Ishikawa diagram, and it gives you know if impact or effect is coming, what could be the reason from personal point of view, from machine point of view, material, methods, measurement, and environment. So these are the different, and you can put the variable here, and you can make a very good fishbone diagram. So fishbone diagram can be a scatter plot is nothing but like you look into the correlation. Box plot is nothing but 5 point summaries: minimum, maximum, Q1, Q2, and Q3, or Q1 median, Q3. So fixed box plot explain 5 number summary. Fishbone diagram is right here. Check sheet is like checking sheet that this part has done, this is done. So these are all, and then control charts. So for our purpose, we are going to learn control charts. However, all these things can be made in Minitab if you have data, and very easily. So this is Fishbone or cause and effect or Ishikawa. If you go under graph, and here you have uh, box plot option and a scatter plot, box plot. So you can have all the options under Minitab. Now we are going to do run chart, and we are going to see different charts. So Pareto diagram, a scatter plot, box plot, check sheet, fishbone chart. So this is like, this is impact, and what could be the reason from pupil point of view, from methods point of view, material, management, measurement. So this is the picture explaining the causes of an ultimate effect. Total quality management means quality in everything that we do. So basically, all theoretical aspect or your that is for reading and understanding, and probably you will be doing the operations management courses with Professor Dunlap, and there you will learn. Most important thing, we have three charts, common chart. So this is X bar chart, which means X is sample, and bar means sample means chart. R chart, which is a range chart, and P chart is proportion chart. So these three charts are important. X chart, R chart, P chart, and most important theoretical thing that we need to understand the upper control limit and lower control limit. So upper control limit is equation is this, and lower control limit is this. For unknowns mu and sigma, this is totally based on, you can clearly see this is totally based on the sample. X bar plus 3 uh, standard deviation of sample, square root of sample size. So this is all plus minus 3 sigma, you remember from previous class. Now this is most important slide. Single point outside 3 sigma. If you look into this, this is the case. This is plus 3 sigma, this is minus 3 sigma. And and the variation is here. If single point is outside 3 sigma, that means the process is going out of range. And if we check that, we need to take the actions, we need to correct it. 2 or 3 successive points outside 2 sigma. So basically, this is sigma, this is 2 sigma, this is 3 sigma. So if you see, this is mean, this is sigma, this is 2 sigma, this is 3 sigma. This is minus 1 sigma, minus 2 sigma, minus 3 sigma. So this is plus minus 3 sigma on both sides. So this is single point going outside. That means your process is bearing such a way it is going beyond the limit. Everything 99.73% should be within plus minus 3 sigma, as we remember from the past class. Same thing is here. Here it is 2 points outside. So if you see 2 points outside, this is the situation. Is it, sorry, I need to check where you see the 2 point outside 2 sigma, 2 successive points. So 2 sigma is, okay, here is the 2 points outside 2 sigma. That is also cause of concern. Continuous to 4 or 5 successive points outside 1 sigma. So this is 1 sigma line or 4 or more points. This is also 9 successive points on the same side of the center line. So 9. So these are the 4 things that we can look. How many points would be? Only 1 point is sufficient to say that the quality is having quality is having the concern. Only one. If you see this, this. So this is called 4 rules. And detecting abnormal pattern means something is not good. And one has to check, one has to correct and take the action. How we can plot these things, I'm just going to demonstrate. So here, this is also based on the empirical rule, 68 plus minus 2 sigma plus minus 3 sigma. Then P chart. one more important thing, then I will. Process capability is this, and CP index. And here you can understand one important concept. How much margin do you have here? Here, if CP equal to 1.3, you have this much margin that you can take the leverage here. If CP is 1 means you are just touching the boundary conditions, means your process is touching the boundary condition. You don't have any margin of error. If you go little bit here or there, means your process is out of control. Here, CP is 1.33. That means you have both sides 1 sigma margin. Here, if CP is 1.67, you have 2 sigma this side, you have 2 sigma this side. If CP is 2, you have 3 sigma this side, 3 sigma this side. What we understand, this is the, at least we need to keep this margin. Means we need to get CP equal to 1.33. If we get this much, we have sufficient margin to play with. So this is always more than greater than 1.33 is considered good. Whenever you do this calculation, make sure that if it is coming 1, it is means you don't have any option to. So this is about quality tools. Let me show you some. And then other things like supply chain and quality awards, ISO, Six Sigma, Lean Six Sigma, ISO Malcolm Baldrige Award, all these things related to theory. Most important is to look into the control charts. So here, let me download some data and then I can show you the control charts. This is the question that we have in our. Uh, so here we have the all the samples in one column. Here we have all different samples in different columns. So I just copy from here and I paste here. Oh, I just copied only one. Something wrong. Why I'm not able to.
I think maybe you just need to scroll up on your worksheet, right? Because you're on 25.
Oh, okay. Just. Oh, sorry. Thank you. Yeah. Thank you so much. Okay. Now I go. Let me copy again. Yes. And this is right here. Yes. Thank you so much. I did not notice. So this we have a six samples, sample X1. So what happened if production is going on? Let's say iPhone is manufactured in any facility. So morning 10 o'clock, you went and you took 10 iPhones or 14 iPhones and you measure the weight of 14 iPhones. So this is at 2 o'clock, you took another sample and you measured this sample, or you noted down the weight of all the iPhones or all the products. Same time, 3 o'clock, 8 o'clock, or maybe some different dates. So you measured these six, you took six samples. Now we would like to see whether, and this is the mean of all. So I go here, statistics, and under statistics, we have, sorry, control charts. And here we have X bar R chart, X bar chart, R run chart, and S chart. So now all observation in one column or different columns. So I just take 1, 2, 6. These are, and we have different things. Here you can do all the things. You have other things that you can put here. Limits, you can decide the upper limit, lower limit. You can do upper standard deviation limit bound means you can put all the variables here. And here you have the, now let's do multiple graphs. Okay. And here you can see this is your lower control limit and upper control limit. Now think about whether you are getting this about 2 sigma, or this is you are getting about 1 sigma. How we can check? So we can check with, calculating the standard deviation. Standard deviation will be here. And you can put, I think this is more than 2 sigma, 2 consecutive, more than 2 sigma limit, or maybe under limit. So basically, when you look, this this graph is looking, this control chart is looking perfectly all right. Upper and lower, everything is within this. Only these two consecutive or three consecutive things you need to check. So there is also under assistant, and under assistant you have control charts. And here you have the option X bar and R chart, X bar. So look into that. It is continuous, collected in groups. Yes, we collected in groups. Yes. Subgroup size 8 or less here, and subgroup size 8 or greater than 8. So we go here. And here you can see how do you determine the control limits? Estimate from the data, or if you have some known values that you can assign lower, upper, lower, upper. If these are given, you can put here and they will appear on the chart. But let me do from the data itself. And here, this is your X chart. This is your range chart. So here, and this is also commentary that you can read about. No subgroups out of control on either chart. Similarly, you can do all kind of charts just by using control charts. Under assistant, you have X bar, S chart, run chart. So most of the questions are related to X chart, X bar chart. Okay, so this is the way. Here we go when we go under statistics and control chart. X bar R, individually you can do. For example, here If I do here data options, X bar options, here you can estimate the, and here you can provide the limits. This means you can provide the data that may be given. These things we don't need to check. Yeah, so you can decide the mean standard deviation. So this is the only thing that we wanted to do in module number 5. But it has many significance related to quality control. If you read the chapter and go through the chapter, it has a lot of concepts that everyone should keep in mind while doing quality control. So this is about module number 5. Now, today I would like to also cover module number 6. If you wish, I can continue, or if you don't want, I can do for next Monday. It's all up to you. Saturday? Because next module will start and that will not be in the exam. That module will start on Saturday. So it's all up to you because only I think 10, 12 students they attend. So if you want to do that today, I'm free. If not, next time, Saturday, Sunday, Monday, either day I will do that. Because that is very interesting topic and that has real applications in managerial decision making based on multi-criteria decision making approach. Okay, let's do it. Perfect. So basically, I would like to share a situation where you have many situations, like you want to buy a house, but one house has good constructs yard, one is good neighborhood, one is a price good, one is new construction. Means one house has some feature which is good, other house has different feature which is good, and you are confused in which one to buy. Or simple question is, three, four cars are in front of you. One is good mileage car, one is good looking car, one is good reliable car. Which one you will buy? And how best a car can be selected? And for that purpose, or how you have three employee, or you interviewed three people, and you want to select one. Who is the best one? And what is the criteria for that? And we are going to learn that one. It's called, let me download the slides so that I can easily explain. It's called analytical hierarchy process, AHP. Based on that, there are other methods, analytical network process and fuzzy AHP, and different methods are there. We are just going to learn the very simple and very basic method. Just a minute. Okay. So you have, can you see my slides part?
Yes, we can.
Okay, perfect. So let's take an example of you want to select a new car. And three criterias are there: fuel economy, reliability, and style. And you have four models: Civic, Saturn, Escort, and Miata. Which one will you select? And now few numbers and few things are given. So based on that, we are going to make decision. Similarly, if you have like, situation where you want to select who will be the next CEO of your company, you can select what should be the preference in a restaurant, or what is the preference of US consumption. All such things can be done here. So let's look into the very simple thing. You have three criterias: style, reliability, and fuel economy. And you have Civic, Saturn, and Escort, and Miata. Now we would like to check which one is. So I'm going to use Excel. In this module, we need to use Excel. Okay, so first we need to decide, we need to do the pairwise matrix. Pairwise matrix is very simple, and that can be done like this. For example, this is Seattle and this is Spokane. One, if one means both equal, and if I say on this side, 2, 3, 4, 5, and if I do this, 2, sorry, 2, 3, 4, 5. So first thing is pairwise comparison. Let's say Seattle is three times bigger than Spokane. Then how you can say Spokane in terms of Seattle? Certainly, Seattle is three times bigger in terms of population as compared to Spokane. Then I would say Spokane is one third of Seattle. Can I say that in simple term? Seattle. Similarly, preference is given here. Style, for example, style to reliability. One means both are equally preferred. Means style, but if pendulum goes here and pendulum goes here, let's say I put here Seattle is three times. So in our matrix, Seattle, if I see, is three as compared to Spokane, and Spokane will be one third of Seattle. Is it making sense? If style, I would like to prefer reliability 10 times more than style, then my scale would be here, let's say I would like to prefer 10 times more reliability in my car as compared to style. Then style will be one third of reliability. Is it making sense? So similarly, here combination becomes uh, how many combination can become style to reliability, style to fuel economy, reliability to fuel economy to means all permutation combinations. So this is the first matrix that can be created. So we are going to do the exactly, and let me show you. So style, reliability, and fuel economy. So I do here style, style to style, reliability, reliability, and fuel economy. So I made this. Now reading is like this. From here, this is the row is the reading. So I just put, this is the reading way. So style to style is one, reliability to reliability one. because they are equal. And now I just make little bigger so that, and I make insert. It looks now good. Okay. Now, based on this, style is half as compared to reliability. Means reliability is twice preferred as compared to style. So reliability is twice preferred as compared to style. So we can put reciprocal or these kind of metrics. So either way you can look. So style is 1 by 5, 1 by 2, which is zero point 0.5. So I can directly write 0.5. Here, this is preferred twice. And now look into the second thing. Style is 3 times preferred as compared to the fuel economy. Okay. Style is 3 times preferred. He is not interested in fuel economy, but he is still. And fuel economy to style is preferred 1 by 3, which is opposite, which is now reliability to fuel economy. So what is preferred here? Reliability is 4 times preferred as compared to fuel economy. So reliability is 4 times preferred. So fuel economy is 1 by 4. Now this is our very first step. It is called pairwise matrix. And how we get this data? This data you can check with the different opinion. Like, when you interview someone, you make your scale, which side you want to give. And you have some criteria if you are interviewing someone where you want to give the, the where you want to give the weightage, which side, and what should be that. And if you have group of three panel or three panel members in a group to select someone, you can aggregate three people and you can make this matrix. So this is very first matrix to be made. After that, we are going to normalize matrix. Normalize. What is the meaning of normalize? Nothing. What we are going to do, sum of entire column, and we are going to make out of 1. So how we can make this? We can make using the same thing. Let me do this. Okay, so normalize, what I need to do? This has to be divided by the total sum of the column. Why we are doing? Because we can convert everything in terms of 100 or in terms of 1. So this, and then this one divided by this. Same thing we can do for second column. 0.5 divided by 1.75. Then 1 divided by 1.75. And then 0.25 divided by 1.75. Same thing we do for third column. So this is 3 by 3 matrix, but it can be 5 by 5 also. Means you can go up to, if you have multiple options, multiple criterias, you can go for longer matrix or bigger matrix. Now, how we can check whether it's normalized? The sum of the entire thing should be 1. Look into that. So we have converted out of 1. Now we take the average. And this is called priority vector. So those who have studied matrix in their, and we are going to take average of average, and we are going to look the same. And here we got the numbers. So this is weightage of style is 32%, sorry, 32%. Reliability is 55% and fuel is this much. So when you do the assignment, don't round up the numbers. Use the exact numbers. That is most important. So style has 32%. So first criteria has been done, which is so having this now they are just rounding up here, so we don't need to care about, but you just do. So here first criteria style is this much, reliability and fuel economy is this much. Once you do that, there is also consistency index. The consistency index is this is the original matrix. These are the priority vectors, and we multiply this matrix with this, and we get AX, and then we do this little calculation in order to check CI and CR, consistency index and consistency ratio. So this calculation is little different than the previous one because multiplication of two matrices is little challenging and little different because usually students finish here and they just based on that they would like to check. Here, look into this. So this is our original matrix. This is our original matrix. I copy here. And this is our priority vector. So I put this vector here. This is right here equal to this. I put this right here. And I put this right here. Now we are going to multiply. So how we are going to multiply? This has to be multiplied with each of them. So this multiplied with this, this multiplied with again, and then this multiplied with this. Same thing for second, this multiplied with this. You can create the macro and you can make out of, very easily. I'm just doing cell by cell so that everyone can understand. This multiply by this. Same thing you can do for 3. And 1 multiply. Okay, now we got this. We multiplied this. Now here we did average. This is the average of the row. Now here we are doing the sum. What we are going to do? Sum. So remember here. So we are doing sum. 0.960 point. So we got this multiplication of this and this. Here they already rounded it. Now how we can get x, lambda max, and this will be divided by this value. This will be divided by, where is the second value? This. And this will be divided by this value. So this is what we can get. So now the next step is, so equal to sign this value divided by, where is this one? this value divided by this value, and this value will be divided by this value. So we got these numbers, and this is called lambda max. So lambda max, and this is x. So lambda max equal to average of all these three. So we are going to take the average, and we are going to take average of all these three, and which is coming 3.018. So this is average. So remember this we have done the sum. Don't get confused. And here we did average. Okay. Now we get this value, very important. And now we get we come very close to our answer. So this is here, and consistency index is lambda max minus n. We have 3 by 3 criteria here. So n is 3 equal to divided by n minus 1. So we are going to calculate consistency index. So consistency index equal to this minus 3 and whole divided by n, which is 3 minus 1. And here we got this. So consistency index is this. Now we are going to check consistency ratio. And consistency ratio is nothing but consistency index divided by Sati index, who discovered this method. So Ci is this much, and then consistency ratio is Ci divided by this. For one variable, this is 0. For two, 0. 3 is 0.58. 4 is 0.90, and depends on the number of items in the matrix. So basically, for us, 0.58. So this divided by 0.58, and we get about 1.58%. And now look into the results. If we get these values, here is the house. If this is 10% of less, implies that everything is perfect. So basically, our rule of thumb is we need to get less than 10%. Then our matrix is all fine. And here we get whatever we are doing is all fine. So we get about 2% here. So basically, this is the priority vector. This has given us first level of this. This now second level, we are going to look for only one thing, which is style. And we have style, and we have 4 options under style: civic to civic, Saturn to Saturn, escort. And then in style, you can rate whether civic is 1/4 of Saturn. In style, civic is 4 times better than escort. In style, civic is 1/6 of Miata. And keep doing this in style, keep doing in reliability. And fuel mileage you can do simply by statistics given by the car company. Civic is 34 miles per gallon, and this is, you normalize and you get the value. Once you get these values for this style, you got reliability, you get, and fuel economy, then very simple. For Civic, reliable style is 0.3, Saturn is this, Escort is this, Miata is this. Reliability for all cars, and now you can decide which one is going to be the best choice for you, which one is going to be the second choice. Very simple. So you just need to, where am I? Okay, here this is zero point 0.3, so you multiplied with zero point 0.3 here, multiplied with zero point 0.3 here, multiplied with zero point 0.3 here. Means you multiplied this zero point 0.3 with everyone. 0.3 plus, 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 plus zero point 0.6 multiplied with zero point 0.6 into zero point 0.6 into zero point 0.6 into zero point 0.6 plus, 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 plus zero point 0.10 into zero point 0.10 into zero point 0.10 point. Now you do the composite score or composite or overall score of civic. When you do this calculation, you will get overall score of the civic. Similarly, you will get overall score of Saturn, and based on that, you can, so based on this matrix, this is the overall score of. Now look into the civic is 30%, Saturn is 27, Meta is 35, and Escort is. So basically, your first choice is, you can rank also. This is first choice. This is your second choice. This is your third choice. And this is fourth choice based on composite score or overall score. And this is the way you can select. You need to go with Meta. And if you don't get, need to go with Civic. Third option is Saturn, and fourth, this is the order. Similarly, real data that has been done in the past. Is it clear to everyone? It needs little practice. So look into this. If you have three house, 1, 2, 3, and you have criteria, size, transportation, neighborhood, age, yard, and all, finance, condition, all, and you can make your consistency ratio is less than 10%. So based on that, you can see which one is, and you can go for house size for all three house, transportation for all three house, yard, and keep doing all. And your overall A house is 34.6%. 30 B is the best option, second is A option, and third is this. Now, third, this is the real data, real statistics done in USA. Which drink is consumed more in USA? And this is a judgmental sampling or pairwise sampling. Based on that, so you can compare yourself. This is based on the judgmental sampling, and means this is based on AHP, and this is real. Look into how close is this. 33%, 32.7, 33, 12.9, 14, 19, 18, 11.6, 12, 0.4, 4.2, this is 4, 0.19, which is about, 2%, here 1%, coffee is 17.7, 18. So this is the real difference you can see. So basically, sometimes this method is also a very, very popular to do this kind of work, where you can compare with real statistics. Same thing is which protein has more food, and you can compare this pairwise matrix, and you can compare with real, and you can look into this. So this is from ASP, AHP, and this is actual. And based on this price, this model, this matrix, 30 point, 34.5, 37, and you can compare. And consistency ratio is 2.8% of approximately 3%. So this method is very applicable and very useful. Now, if you get a choice, Mr. Clinton, Margaret Thatcher, George Bush, you can select your CEO based on different criteria, like, you have education, experience, working in the same industry. You can make many criteria and you can hire who is going to be the next one. So this method is very useful and applied method. Any question related to this? After this, we have one more thing, which is called project performance. How do we check the project performance? So basically, which is very easy, and my previous recording also has that. Uh, Recording is there, which I will share. If you want, I can explain also. If you are available, I can explain. I can continue explaining. Uh, I need your opinion. Everyone? Okay, so here we go. Okay, perfect. So, earned value analysis. Actually, this is very useful in any project management. So, those who are project management people or working in project management, they know this method. This is very popular. It requires three items: present value, earned value, and planned value. So, based on that, you can check your project performance, you can check your project status. So, planned value, actual cost, and earned value. How you can check these three things? So, basically, every project has planned value. Means by this day, let's say you plan, by week number 6, 30% work will be done. So, this is when any project start, and actual, you can see today 24% only work done. And actual cost, you can get to know from your account, $2 million or whatever money is spent so far, that you can get real time because accounting keeps everything. So actual cost so far, and earned value. What is the value you earn? How much work actually done? So based on that, we can do this. So if you know these three numbers, rest is all fine. So any project, you first need to understand how much is planned value. And if you are able to figure it out, these three numbers, rest is very easy. So look into that. Very simple numbers. Here, if you see activity one, and this is very helpful, you can decide any time. Let's say you want to do today to check the health of the project, how it is performing. So let's say today, by this time, four activities are there. Activity one has to be completed by today. Okay, it is done. Activity B has to be completed by this day, but only 80% is completed. Activity C has to be completed 80%, but only 70% is done. Activity D has to be completed 15%, but nothing has been done in this case. So, what is the planned value by this time? You can clearly see, you can clearly understand. 18 from this, 10 from this, 20. So basically 80% of 20 is 16, and 15% of 40 is 6. So this has to be planned value. Planned value is 50 by this day. Okay. What is earned so far? How much has been done? Okay, 18 is done. 80% of 10 is done, 8 is done. 70% of 20 is done, 14. And this is so as of now, only this is earned. This is the earning. And from actual accounting, you can see 45 is tracking. Actual cost is 45. So from accounting, you got these things. Based on these numbers, you can perform these. simple Q calculation. So cost CPI, cost performance index, and schedule performance index. You can do both of them. Cost performance index is VCW, which is this. What is VCWS, which is plant value, and earned value VCWP. So VC, which is plant value and actual cost, and earned value. Sorry, I just VCWP. So this is a plant value. Yeah. So VCWS is plant value and P is actual cost, and earned value is WP. Okay. Earned value, actual cost, and okay. So if you put these numbers here, VCWP and actual cost. So, and VCW, and this is plant value. And if you put these numbers here, if cost performance index is greater than 1, means it's a great performance. If less than 1 is poor performance. And how we can check in this case? So look into this example here, very simple. You want to make 1,000 cups over 50 days, means every day 20 cups every day of lemonade. 20 cups per day, each cost 50 cents, and total budget project is $500. Now they have decided to check this on the end of day 10. End of the day, only 150 cups are made, and the actual cost is paid $90. So basically, we can get to know three numbers. Three numbers, how we can see. So this is actual cost, which is clearly from accounting. 100 cups, this is earned value. Earned value means 150 into 50 cents, 0.50. Earned value is $75. But you know, the plant value was 10 days into 20, which is plant value was 100, because each day 20 cups, so 10 day, 200 cup, and each cup costs 50 cents. So we know these three numbers. Now we know three numbers. Using this, we can see very simple. So we would like to check the schedule performance index and cost performance index. These two numbers are very important in order to tell the story. Cost performance and schedule performance index is 75 is earned value. And what is the plant value? 100. So we got this. And 75 is earned value, and actual cost is 90. So we got this value. Now look into 0.88 this and look into this number. Based on that, we can get to know how, if we go with the current speed of current way of flow, when this project will be done. So actual cost was $500, and this is cost performance index is 833. So instead of $500, this project will be done in $600. Similarly, schedule performance is 50 days of schedule, but you know, instead of 50 days, it will be done in 66.67 days. Now only 10% or 20% of the work time has been done. Means only 10 days gone. You have still 40 days in order to make up this time, in order to make up this cost. So this is you did, 10th day, you have 50, you have 40 days. You can tight your management, you can tight your production, you can tight your workers, you can take corrective measures in order to make this things within time, within budget. So this is very simple example, but if you have bigger project and bigger things, everything, all these numbers you can get through Microsoft project or project management softwares. So uh, this is the earned value analysis. Is it clear? Any question? If no question, then yeah, have a wonderful evening.
Lester,
Wonderful. Yes.
I do have a quick question, but it wasn't about what we just went over. Um, and I might be getting a little bit ahead of myself here, but we're a little less than 2 weeks out from the final. Is there anything you would recommend us to touch up on most? Should we review little bits and pieces of everything we've learned
So
throughout the last 5 weeks? What do you recommend?
So, the 5 weeks, first 5 weeks will be covered in the exam, and whatever, MCQ and fill in the blanks that you have done in the uh, uh, every week. The same question will be there, 40 questions will be there, and if somebody is studied, it can be done in 20 minutes. The final exam can be done in 20 minutes,
Okay, perfect.
honestly.
Sweet. That gives me and my classmates a starting point. Good to know. Thank you.
Most welcome. Yeah, it will be very easy conceptual ways. Because I have seen in the last times, 20 minutes are sufficient for those who have studied.
Awesome. Well, I'll
Okay,
get to it. Thank you.
most welcome. Bye bye. Good night. And I will post this recording. Thank you.
Thank you.